to find the derivative of this function y in the form of the cube root of the quantity 2x minus 7 divided by 3x plus 4. First, we're going to write the cube root as the power 1 over 3. And then we can see this as the power function has composed with the other function. So to find the derivative, we're going to use the general power rule, where the function gx, which is the inner function in the form of 3x minus 7 divided by 3x plus 4, and the power n is 1 over 3. Or the other way, we can write y as the quantity of the function g raised to the power 1 over 3. To apply the general power rule to find this derivative, which is another way to say we are using the chain rule. So since this is in a power form and composite with the other function, so we just refer to general power rule instead of saying the chain rule, which is exactly the same thing. So the y prime gonna be, this is the quantity gx to the power n. So the derivative of the y gonna be n multiplied by the quantity gx raised to the power n minus 1 and multiplied by g prime of the x. The problem already provided the gx, which is the inner function. I'm going to put a note here. This is called the inner function. And then since the n or the power is 1 over 3, we have the n, we have the gx, and n minus 1, just subtract 1 over 3 by 1. But we still need to find the g prime. So on the side notes here, I'm going to go ahead and then find the g prime, which is the derivative of the quotient, like 2x minus 7 over 3x plus 4. To find the derivative of the quotient, we're going to use the quotient rule. And when we work on the quotient rule, most of the problems refer this function as a high function divided by the low function. So the formula to find the derivative of the quotient or the quotient rule is, I'm sorry, so it is in a form of the low d high minus high d low, draw the line, and low squared. It means um, we're gonna need the, we know the high is 2x minus 7, the low is 3x plus 4. So the d high is the derivative of the 2x minus 7, which is 2, the d low, which is the derivative of 3x plus 4, which is 3. So we get all pieces. We're gonna bring these 4 pieces information into the formula to find the g prime. And keep going with the same color here. So then my g prime on my side note here, the low, which is the quantity of 3x plus 4, the d high is the value 2 minus the high function, which is 2x minus 7, multiplied by the d low, which is the value 3, and all divided by the lower square, which is the quantity 3x plus 4 squared. And then as a routine work, we're gonna simplify as much as we can for the expression as a numerator. Then we multiply 2 to these 2 terms and 3 to these 2 terms. 3x times 2, that's 6x. 4 times 2, that's 8. And then 3 times 2x, that's 6x, but we have negative sign in the front. 7 and 3, that's 21, but 2 negative side becomes 21 positive side. And all divided by the quantity 3x plus 4 squared. The numerator shows, just a second. So the numerator shows some term that we can cancel. So we're gonna reduce the 6x and 6x quantity, and then 8 plus 21, that becomes 29. The numerator is 29 divided by the quantity 3x plus 4 squared for the denominator. On the side here, we get all the prep work. And now we're gonna bring everything into the main part of the problem. So our y prime, which is n, n in our case is 1 over 3, the quantity of the gx, which is the quantity 2x minus 7 divided by 3x plus 4 raised to the power 1 over 3 minus 1, and then multiply by the expression for the g prime, which we just derived, or the expression 29 divided by the quantity 3x plus 4 to the power second. And then simplify as much as we can. We have 1 over 3. The power here becomes negative 2 over 3. So then we can write this as the quantity 2x minus 7 divided by 3x plus 4 raised to the power negative 2 over 3 and then multiply by 29 divided by the quantity 3x plus 4 to the power second. So this considered as one of the complete form, but as you see the negative power here, you can rewrite as a positive power. And also the coefficient 1 over 3 and the number 29, it can be put together as 29 over 3. And then with the negative power, we can write as a reciprocal. So it can be 3x plus 4 to the power 2 over 3 divided by the quantity 2x minus 7 to the power 2 over 3. And then multiply by 1 over 3x plus 4 quantity power 2. After we wrote it in this form, you can see that we have the 3x plus 4, 3x plus 4 both on the numerator part and denominator part, but they don't have the same power. The power of the numerator is 2 over 3, but the power for the denominator is 2. But we can adjust by rewriting in the nice form. So this way, we're going to gather them into the denominator. So we have 29 over 3 multiplied by 1 over the quantity 2x minus 7. We have nothing to do with that. But the quantity 3x plus 4, we can combine the power. So we're going to subtract them. So 2 minus 2 over 3. And then the final form, the more simplified form of this answer, going to be 29 divided by 3 multiplied by the quantity 2x minus 7 to the power 2 over 3. And then multiply by the quantity 3x plus 4 all to the power. So 2 minus 2 over 3 is the same as 6 over 3 minus 2 over 3, or just the power 4 over 3 as the final result. So this is the answer for this problem, or the value or the expression for the y prime.